ID, the Future, a podcast about evolution and intelligent design.
Welcome to ID the Future. I'm your host, Brian Miller. Today I'm welcoming back to the show Elie Feder and Aaron Zimmer to discuss the second season of their podcast, Physics to God. Elie Feder earned a PhD in mathematics from the CUNY Graduate Center. He has published widely in the field of graph theory, and he serves as mathematics professor at Kingsborough Community College. He is also an ordained rabbi. He hosts the podcast Simply Deep, and he recently authored the book Gematria Refigured, which addresses fine-tuning in Torah, life, and the universe. He resides in Far Rockaway, New York, with his wife and their 4 children. Now, Aaron Zimmer earned a physics degree, and he is also an ordained rabbi. He has also studied philosophy, mathematics, and psychology. He's a true polymath. But what's really interesting is he applied his knowledge of these different disciplines to become a highly successful commodities trader. He resides in Lawrence, New York, along with his wife and their 5 children. Aaron currently co-hosts the Physics to God podcast, with Elie Feder, which is the topic for today's show. Now, I interviewed these 2 rabbis in the past, and it was a really wonderful conversation. And what I greatly appreciated is that Elie has this passion to explain complex ideas in very simple terms, while Aaron ensures that arguments are comprehensive and rigorous. So they make the ideal co-hosts. Now, just for the first question I want to ask, could you please describe your podcast just to remind our listeners and summarize the first season?
Okay, so this is Aaron, and it's good to be here again, Brian. We appreciate it. Our podcast, Physics to God, there was planned 3 seasons. The first season we already did. It was 10 episodes, and in that first season, we took what we would describe as 3 essential components of the universe: the laws of nature in the qualitative sense, the quantities of nature, the constants, and the initial conditions. And we showed how they're all designed, fine-tuned, and ordered. So the first argument we started off with, which was 5 episodes, was the fine-tuning of the constants of nature, to show how the quantities of, for example, how heavy, how much mass an electron has, the fundamental particles, or how strong the fundamental forces are, showing that those constants, those were certain numbers that are fixed numbers in nature, and they are precisely within the range that allowed for a complex, ordered, structured universe to emerge with atoms and molecules and planets and stars. And the second argument, we showed that the laws of nature themselves, general relativity and quantum mechanics, were precisely there was no logical necessity for them, and they were specifically designed to allow for our complex universe to emerge. And our third argument was the initial conditions at the Big Bang, that they were ordered in a incredibly unlikely way, purely in a probabilistic sense, that would allow our complex ordered universe to emerge, as opposed to being a universe filled with black holes. And the entire objective of those 3 arguments, they really were independent arguments, was to show that our universe must have had an intelligent cause for the qualitative laws, the constants of nature, and the initial conditions.
Oh, thank you very much. And I very much enjoyed the first podcast, but even beyond the science you talked about, what I really found fascinating was your own stories. Could you please share with us again of how you met and what inspired you to launch your program?
Okay, so this is Elie. So Aaron and I go way back, 25 years. Aaron and my brother were buddies in high school. And I was a rabbi at a yeshiva, the yeshiva which we study in Far Rockaway. And we started studying together. We studied Talmud, and we've basically been studying together for 20 years or so, almost every single day. We study Talmud. And the way we study Talmud is with something called the Brisker methodology. And it's basically like an analytic way, an analytic approach towards studying the laws of the Talmud. And basically the nature of our interactions and our learning is very much thinking, categorizing, defining, conceptualizing. And we've been studying for a very long time together in this capacity. And besides just studying Talmud, we're both interested in physics and philosophy and psychology. So we just discuss a lot of different topics. So, we discuss physics a lot. Aaron's physics guy. So one day he came to me, and this is maybe 15 years ago. And he said he just read this book by Elies called Life of the Cosmos. And Elies is an atheist physicist. And in this book, he talks about these constants of nature. And this is, going back 15 years. So he talks about how these constants of nature, no one knows how to explain why the numbers are fixed how they are. But it was discovered that they're fine-tuned, that these values are within a small range of values, which allows for our amazing ordered complex universe to emerge. And I think at the time, Smolin's, in his book, he calculates the odds of that happening by chance alone is like 10 to the 250 or something like that. So Aaron says to me, Elie, this is unbelievable. This supplies an argument for God. Smolin's obviously not saying that, but this is great. So then we discussed it back and forth a lot. And Aaron, we were both very excited about it. So Aaron presented it to a group of our friends, and they liked it. But the thing is with physics is hard to teach to people. People are scared of physics, and it's just no one really believed that Aaron and I had an argument for God from physics. It just doesn't. It's hard to believe, and no one really believes us, and it's hard to really convey to people because the physics is always complicated. And then that was then sometime later, maybe a year later or so, Aaron read a different book by Martin Rees called Just Six Numbers. And there he presented, again, 6 numbers, which were fine-tuned, and our universe totally depended upon these numbers being right. And at the end of his book, he has a chapter where he says, okay, so one might think that this points to a creator or to God or whatever, but I think there's another compelling, interesting possibility, which is that of the multiverse, that there are infinitely many universes out there, and just by chance, we happen to be in the one universe that allows for intelligent observers to emerge. And when Aaron saw this, he came back to me and says, Elie, I think we have it. I think we could use this to show people that fine-tuning is a real thing. Because if scientists, the top scientists, are positing infinitely many universes to explain our one fine-tuned universe, this you could show people this is not an order. There's a real problem. There's the only other solution is a multiverse. There's something here. So then we decided, we got really excited. We decided to make this is the time where blogging was big. So we had a blog, which we called Blog O Shir. Shir is like a Talmud class. So we called it Blog O Shir. And on our blog, we wrote a lot about fine tuning. We had a lot of, we had followers, and it was an active discussion. We got really excited about it. And we developed the argument much more further, much better through our discussions back and forth. We had some atheists on the blog, so it was very, interesting. And then after the blog closed down, we decided to make it into a book. We thought it would be great to write a book. So we spent like 10 years or so writing a book. And we got our argument really solid, but really dense in a way that was very hard to read. So we gave it to people to read, and there's like, wow, but it just didn't work. And then someone suggested we make a podcast. So a podcast, we just thought, we are teachers by our nature. I teach in a community college, and we both teach Talmud. I teach math. So it's like we thought it would be we'd have a good give and take. So we decided to make it into a podcast where we'd really try to spell out the argument slowly, step by step, in a friendly, accessible manner. And here we are today.
Well, I greatly appreciated the first season. And I'm wondering, in terms of people that watched the first season, what did you hope they would gain? You've already alluded to that, but what were sort of the takeaways that you hope that they would carry with them?
We knew that fine-tuning, we're not the first people to discover fine-tuning. There are other people who discuss it. Luke Barnes and Robin Collins has written papers on it, and there's a lot of people. It's a fairly well-known phenomenon. But we thought we had a pretty unique formulation of it. And a lot of the problems that atheist scientists were asking or were questioning against the fine-tuning argument, we thought were a product of the specific formulation that had might have holes in it, might have weaknesses, and we thought we wanted our listeners to know. We want them to know that we want them to realize that, first of all, fine-tuning was the most convincing argument out there. We think of for God, we think it's the best in all the sciences. We really think it's the best, specifically of the constants, even better than the laws and the initial conditions. It was fine-tuning of the constants. and to realize that fine-tuning isn't the problem. Everybody presents it as fine-tuning is the problem. You have these numbers, they're a specific range, in order to allow a complex universe, intelligent life, and then how does it get there? It must be God. And then you say it that way, it sounds like it's a God of the gaps argument. And we want them to realize that no, there's really an intrinsic mystery about these constants that has nothing to do with fine-tuning. And Richard Feynman in the early 1980s, he called explaining the constants one of the greatest damn mysteries in physics, and fine-tuning wasn't even well known at that point in the 1980s. And it has nothing to do with fine-tuning. It's just you have these numbers, 25 numbers, that are the fundamental quantities of nature. And there's this deep mystery in physics itself of how do you explain a number? And it's like an abstract problem to understand. Physicists don't want to say 25 numbers are fundamental and they have no deeper cause, no deeper explanation, because it's 25 arbitrary, ugly, random numbers. That's the ultimate reality. These 25 numbers plus quantum mechanics and general relativity doesn't make sense. It's just not what physicists expect to find at the base of reality. But then how do they explain it? How do you find some theory which pops out these numbers exactly in this way? It didn't seem plausible, and it's an intrinsic mystery. And then as fine-tuning was discovered, over the next coming decades, fine-tuning was the solution. It said there's no mystery, or there's a solution to your mystery, because the numbers are not arbitrary random numbers. They are numbers that are specifically within the range for the purpose of bringing about a complex ordered universe with atoms and molecules and planets and life and stars. That gives you an answer to explanation, a direction to say, well, now I understand about what these constants are. I can solve the mystery because the constants are these specific numbers for a purpose. Now, what that points to, obviously, is that the cause of the constants is intelligent because it operates with a purpose of selecting these numbers in order to produce a certain goal. That is a surprise to physicists who have, and scientists as a whole, who have wanted to remove purpose and teleology and intelligence from the universe entirely. And it presented a tremendous problem for them because of the paradigm, the framework in which they view the natural world. But fine-tuning, by its nature, is a solution to an intrinsic problem that existed. And we just thought that formulation of the fine-tuning argument, it's a much stronger, more compelling argument. It shows people why it's not a God of the gaps argument. You start to realize that fine-tuning is scientific knowledge that's solving an intrinsic problem, and it really helps a person realize why fine-tuning is the most convincing argument for an intelligent cause that we really have from science.
And I really enjoyed some of the analogies you made that really helped to highlight the specialness and how the specialness is a positive case for design. Now, in your second season, what will you cover in your second season, and how do you hope to advance the argument you made in the first season?
Okay, so the idea is that at the end of our first season, the goal of our first season was to show that fine-tuning of the constants, the design of the laws, the ordering of the initial conditions point directly to an intelligent cause. But that's not the only way to explain it. We think that it indicates an intelligent cause, but we realize that there is another solution out there, and that's the solution which is maintained by the physicists who are not atheistic physicists who say, 1 second, there's another way to explain it. And the only other explanation which is out there is this idea of a multiverse. Again, just to back up for a second, is that because the constants are fine-tuned, because we discovered that the constants are very specific values, which only those values which will result in our amazing ordered complex universe, it was no longer viable to just hope that maybe one day we're going to find some mathematical formula which is going to pop out these numbers. We've found what's significant about these numbers. What's significant about these numbers is that they're fine-tuned to be able to, for the purpose of bringing about our complex universe. And just to hope that maybe we're going to find some other explanation, even if we'd find such an explanation, it would be a total coincidence that it happened to line up with fine-tuning. And that's the idea is that once scientists realize fine-tuning, they realize that the way to explain these constants must involve fine-tuning. Now, we think the way to involve fine-tuning is an intelligent cause, but the way that scientists explain it is using a multiverse. And the idea is they posit there's infinitely many universes out there, And if the constants vary and everything varies, everything happens in all these different universes. And by chance, you're going to end up having one universe that's going to have just the right constants and everything is just going to be just perfect. And of course, we happen to live on that universe because we couldn't live on one of these other universes. So this is like their basic solution. And what we want to do in season 2 is to take the multiverse seriously. A lot of people just dismiss multiverse and say, oh, that's wild, science fiction, crazy. And we do agree with that sentiment. It sounds that way. But at the same time, we got the smartest people in the world who are believing in a multiverse. And as such, you can't just push it aside and say, nah, that doesn't make any sense. That's far-fetched. That's science fiction. We have to take it seriously. So what we do is that there's a lot of different talk, a lot of scientists talking about multiverse, a lot of different versions of the multiverse. And what we try to do is we nail down what are the premises, what are the common elements of all the different multiverse theories which are necessary to explain fine-tuning. There's a lot of different versions which don't have anything to do with fine-tuning. Okay, and there's some of the many worlds of quantum mechanics which has nothing to do with fine-tuning. We say what are the elements necessary that multiverse needs to establish in order to explain fine-tuning. And we boil it down, we'll talk about this soon, we boil it down to 3 premises. And we show these 3 premises are the necessary ingredients that a multiverse theory needs to explain fine-tuning. After we do that, we take the premises one at a time and we try to see what are their supports. Do scientists have supports for each of the 3 premises? And we go a few episodes where we discuss the supports. And then we show, after we do that, then we show the real problem with this 3rd premise, which we'll talk about soon, is the typical universe premise. Is this third premise really gets them into trouble, and it really leads to something called the measure problem, and that's what we're going to do on the second season. Like the heart of our second season is going to be to talk about the measure problem and show why that really is the Achilles heel, and it really is the undoing of the multiverse. It leads to the undoing of the theory, and after we do that, we're going to finally have a discussion about why. To what degree multiverse is really science? Is it following the scientific method, or is it really what we argue is to be it's poor philosophy? It's not really science. That's kind of the nutshell.
So that's very helpful. So the idea is that the multiverse is this concept where there's many different universes, and these different universes have different laws, different constants, and we're just kind of lucky because we just happen to be in the one that has the right set. While you're arguing that it's not just that we're lucky, but that there is a clear evidence of purpose and design, which you're going to really flesh out in the second season. That's really exciting. And you mentioned those 3 premises. Could you please list the first 2 and give details about them?
Okay, sure. I just would say one thing, Brian, is for to present the multiverse scientists their view. They wouldn't say we're getting lucky. They say since there's an infinite number of universes and they're all different from each other, it's not luck anymore. It's luck if you have one universe, then you get lucky, and then they agree you can't get that lucky. So that's why they say if you have an infinite number of universes, some of them, and they're all different from each other, one of them is going to look like our own, and of course we're going to exist in this one. So that's because they want to remove luck. They don't want to say we get lucky. They okay, so basically the 3 premises. Let's say we'll start with the first one. The first one is you need a lot of universes. Preferably, they have an infinite number of universes. You need certainly something close to an infinite number because the odds of getting a universe by chance alone, with all the constants right and the initial conditions right, the odds are so staggering. You just need a tremendous amount of universes. And therefore, and the way the scientists actually try to establish that there's a lot of universes is through something called eternal inflation, which is it's based on a scientific theory of inflation, which is the idea that the universe expanded very quickly at the initial stages of the universe. And when you model that theory in the simplest way, you end up with inflation kind of runs away, and you end up with infinite numbers of bubbles where each one becomes a separate universe and they don't relate to each other. And this is like the basic method that scientists have of establishing that first requirement of an infinite number of universes is through eternal inflation. And, we discussed that on, maybe it's the 3rd episode of season 2. And we basically give it to scientists, at least initially. Great, you use scientific arguments to show this infinite number of universes. That's not enough. If you have an infinite number of universes and they're all the same, it doesn't do anything for you. You're left with the fine-tuning problem. Why are your infinite number of universes all fine-tuned and designed? So in order to move beyond that, scientists have a second premise, which is that the laws of nature change between these. In every single universe of the infinite universe, there are different laws of nature. Basically, the two arguments they have.
We call that, by the way, the varied multiverse premise.
Right.
So the first one, the infinite multiverse premise, and not the varied multiverse premise. Yeah.
Right. Okay. So the primary way they really have of establishing is through string theory. Beyond, there's really two methods. One method is, come on, there's no other way that these constants could be fine-tuned were not for the fact that they're different everywhere. But we leave that aside. We don't think that's a real argument. That's not legitimate. They just say God is impossible, and therefore the constants must be different, or else how would they be so fine-tuned? And we give them a lot in general throughout season 2. We want to show that they fail even within their own framework, but we don't give them the a priori assumption that God doesn't exist. The premise is the whole premise of our podcast is you're coming with an open mind. Two possibilities: does God exist? Does God not exist? And if you analyze the universe and study it scientifically and use proper philosophy, would you be led to the conclusion that the cause of the universe is intelligent, or is blind, unintelligent laws the ultimate cause of the universe? So we don't give them the argument that God for sure doesn't exist. We're not willing to accept that as a premise. But the way they establish that the laws of the universe change from laws of nature change from universe to universe is through string theory. String theory has hidden dimensions, spatial dimensions. We explain what that means. And because of these dimensions, and they can be shaped in different configurations, so that would ultimately change the constants of nature and the properties of the fundamental particles. And that would allow them to have the constants of nature be dynamic and changing. And if you put together eternal inflation and string theory, you have their first two premises. There's an infinite number of universes, and the laws of nature change from universe to universe. And that we call that, if you get those first two premises, the infinite varied multiverse. And that's the popular presentation of the multiverse. And most people think once you have that, that's sufficient in order to explain away fine-tuning is just an illusion of an observer bias.
Thank you. That was very helpful. This will be the conclusion of the first part of our conversation, and we'll have the second part in the next session. But for listeners, if you want to listen to their presentation in their different episodes, please go to physicstogod.com. That's physicstogod.com. For ID the Future, I'm Brian Miller. Thanks for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.